Alright, so let me get started with the comment section. So index equals value. So given this array, when an array is given, and what we're going to do is potentially look at its index and their values. For example, 8's value is -8, the index is 0. 0, index is 1. 2, index is 2. And 5, index is 3. So here, there's only one value where its index is equal to the value, which is 2. And we have to return this index or the value because they are potentially the same, it doesn't really matter. And if such index doesn't exist, we should return -1. Okay, let's look at another example. -1, 0, 0, 1. Okay, 3, 2, and 6. It's going to be 3. So there's no such index, and we should return -1. Okay, so let me think about the problem a little bit now. And so one way would be to do it linearly, like go through every value and its index and check if they're equal. And if they're equal, what we're going to do is like break the loop and return the value or index. So this would be a linear solution. So the approach number 1 is to do linear search. So in this case, we'd be using, so the time complexity would be big of n. Like if we have n numbers, we'd go through, in the worst case, all of them. So, and the space complexity, because we're not going to be allocating any extra memory, so it would be constant. So we wouldn't be creating any extra variable, increasing variables. So I believe that because we know that the array is sorted, we have one extra information, we can increase the efficiency for this algorithm and try to do something better, which is going to be my approach number 2. So we're going to do something like modified binary search. Because we know that if the value has increased more than its index, we know that it's never going to be we can make assumptions based on its index and value. For example, here, if it's -1 and 0, that means like there's some index is going to come where, or may not come, where they will be equal. So because we're looking at the least, like smallest index or smallest value, this is possible to look for. So let me take this one and try to do a binary search on it. So we're going to have just the same way as the previous example. We're going to have left and right variables, and we're going to look at the ranges. Okay, so we're looking at this range, whole range, and this index is 1, this index is 0, and this index, so this index is 3. So we're looking at this, the mid value 0, 1. So and I can see that the values on the left hand side are way smaller than their indexes. So that means what can we deduce from that information? If it's, for example, here, the value is still less than the okay, let me take a look at this example first while I'm looking at this one. So what we're going to do here is take a look at the left hand side and the right hand side, and we have to make a decision here. Either we're going to go with the left hand side or the right hand side. So how are we going to make this decision? Is very intuitive because here you can see that its index value is a little bigger than its value. The index is bigger than the value. So what information does it give to us? It means we have to look at the right hand side, because its value hasn't increased yet. So this is the way. So we're going to look at the its midpoint's value and index. If it's too much, we're going to do what we're going to do is we're going to go with the left. If it's too less, we're going to go with the right. So we're going to compare only those two variables, which is the mid of the array value and mid itself. And then we're going to make decisions based on that. So let's go with this example, and what we're going to do is take a look at this. So and we would decrease the search space. It would be this. And we're going to take a look at this, and so this would be 1, 2, and 3. The mid value would be 2, and mid index would be 2, and we would take it as potential candidate and look at the search space for left. So for this case, and then search again if there's potential candidate. We take it, but we don't take 0, 1 because they're different, and we would return 2, 2 here. Let's so you got the idea, right? How we are doing it. So given this array, what we're gonna do is we're gonna find the mid. So it's here, and its index is 1, right? Its index is 1, and its value is 0. The value is too less. We have to increase the value. To increase the value, we have to look at the right-hand side. So we're gonna look at the right-hand side. I'm gonna copy the remaining of the array, the right-hand side, and its value is 1, and it's we're gonna look at this range, and we're gonna see that 2, 3. Here, the value is too big. Value is 3 and index is 2. Value is too big. We have to look at the left-hand side. And we go to the left-hand side, and we exhaust the search space. We're not going to have anything to look at, and we would return -1 here. So do you think this solution is good enough? Should I go ahead and implement it? Okay. All right. So we're going to have 2 variables, left and right. So left is going to be 0, right is going to be length of array -1. And so let me make a little bit of a space here for myself. And while left is less than or equal to right, what we're going to do is we're going to look at, so let me have answer variable here, which is -1 at first. And then we'll do some magic here and return answer. So let's take a look at this. We calculate the mid variable, the middle value, and middle index. What we're going to do is we're going to add left and right and divide it by 2. I'm not going to do floor, like subtract right from left and divide by 2 and then add to left. No, because Python doesn't have integer overflows. So it's not necessary. So I can add them together and divide by 2. Okay, and now what I'm going to do is this if statement. If the mid, which is the index, if index is greater than the array of mid, which is the value, if it's greater than the value, if the mid is going to be greater than the value, we have to look at the right hand side because the value is too small. So what we're going to do is we're going to do right hand side. So to look at the right hand side, what we need to do is to change our left hand side. Left range. Left is equal to mid plus 1. And in the else case, what we're going to do is right is equal to mid minus 1. We're looking at left-hand side. And then we have to add one extra line of code, which is if the array of mid is equal to mid, which is possible, what we do is we update our answer. We update our answer to mid. Okay, so this is complete now. What I'm going to do is simply run this problem for the first array. For this one, I'm going to delete all of this. Okay, so we have this array, and we have variables called left, which is equal to 0, right, which is equal to, so we have 4 elements, and it's 3, and we have variable called mid, and answer which is equal to -1, and mid, how we are calculating, we are adding left and right together and dividing by 2, which is going to be 1. And now we're going to check if mid is greater than the array of mid. Mid is 1, and we're going to take a look at the 1, and it is. The index indeed is greater than the value. Value is 0. So what we're going to do is we're going to change the left variable to 2. So left would be 2. Okay, left would be 2 now, and in the next iteration, we're going to recalculate mid, and the mid would be 2 here because we add 2 to the 3, and this would give us mid value of 2, and we're going to check it, and right would be updated to mid -1, which is 1. Right would be 1 now, and it would stop the loop, while loop, and before that we would update the array, and answer would be the mid value, which is 2. The answer would be, it would return the answer variable, which would be 2, which is correct answer. So what I'm going to do, I'm just going to write assert code here, just to make sure what I just ran through is correct. So how I'm going to do is assert this. Okay, equal to 2. So just to make sure that it works, and executing code. If it gives assertion error, that means something went wrong. We're going to try to find a problem. If it goes fine, like you can run the tests and call it a day. So operation timed out. That means we have a infinite loop. So that means we're going too much. So so what could be the problem here? That our loop is running infinitely. It's never stopping. So our check is left is less than right, less than or equal to right, and we're checking the mid value and then updating left and right by mid +1 and right mid -1. I believe it should have stopped at this point, but I'm not really sure why exactly it's timing out. Not the code. Interesting. Yeah, this is very interesting. Probably their code execution server may be down. That's why it's giving timeout. Okay, so then let's try to run another test in our mind. So the second one, like without using any fancy technology, but try to do it here. So we're going to start right here. Left is 0, right is equal to 3. answer is -1, and mid is, we're going to add 0 to 3, which is 3, and divide by 2, which is 1. Mid is 1. So we're going to take a look at the mid, and the value is 0, the index is 1. Value is too small. We have to look on the right-hand side. And we look at the right-hand side by changing left variable to mid plus 1. Mid is 1, and we look at the right-hand side, and right would be 2. No, I mean, I should update the left variable. Left variable would be 2. So we're looking at 3 and 6, two numbers. And in the next iteration, we're going to add 2 to 3, and we would get the new mid, which is 2. And we look at the 2, and for 2, what we're going to see is it's 3. The value is too much. It's 3. Value is too big, so what we're going to do is we're going to look at the left-hand side, and left-hand side, to look at the left-hand side, we'd update the right variable, and to do that, we would change the right to be 1, mid minus 1. So it would close the loop, and it would return -1 at the end because we didn't update the answer variable. So it's working for both cases. And let me try again and try to, I'll remove this line and run the tests. Maybe it will work. I'm ready to test my code. So it's executing the tests. If it doesn't work, it's still fine. Okay, sure. Mm-hmm. 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 Yeah, 3 elements. Yeah, I got it. So we're going to choose midpoint, which is 1. 1 is exactly the equal to its value, which index, and what we're going to do, we're going to look at the left-hand side and update the answer variable, which is mid, which would be 1. Answer would be 1. Answer would be updated to 1. And we're looking at the left-hand side, and we'd look at the 0, only 0. So, and then come to 0, and then update the answer to 0. So the answer would be 0. So it's working in logarithmic time. It's not running in linear time, so it's still logarithmic time and using constant space. Yeah, I think there's nothing we can do to speed this up. I can't see anything right now. Like, sounds great. Yeah, so before we wrap up, I want to give you some feedback. So how I'm going to give you feedback is I'm going to swap the roles and give you some very important feedback before you go to your next Pramp interview, because it's my like 15th Pramp interview. So I've been preparing for over a year now. So I really need to give you some feedback before you go to your next one. First of all, very important one, do not start coding until you're told to do so, until you're very sure that you can implement simple code. until you yourself understand the problem. Before making sure, 100% sure, do not write any line of code. Do not write one line of code at all. Don't do it. You can even finish the interview with ready solution without code. It's much better than having not working code. So that's why work on your problem very hard, like in the beginning of 10, 15 minutes. Don't worry about writing code. Never. Just take a look at the examples and try to find patterns. Try to find out the algorithm. First of all, do not start with optimal solution. Give like linear solution. Give it approach one. If you're trying too hard and there's like very less time left, I would say, hey, do a linear search here. Like, because you already gave linear approach, so you're missing, like, while you're giving linear approach, you're also, your brain starts thinking in parallel, right? You'll have more time, like while you're saying, hey, this is constant space and linear time, you're still thinking about binary search, right? So that's why I try to give simple solutions, even if they're too slow. And then try to think on the optimized solutions. It's just fine. And the second, so the first one is solve the problem in paper first, like on the board, and then start writing code. And the second thing is you were pausing a lot. You weren't talking. You remember how I did is, even if I was having problems understanding the problem or having challenges, I was speaking out loud. I was trying to say what I was thinking. It's very important. Your interviewer will get bored and then probably leave you, like probably will give you bad feedback because you're not communicating. Like half of the interview, more than the half of the interview should be communicated. Like you have to be communicating constantly. You shouldn't stop talking. You're writing code, talk. Like you should say, hey, this is that. Even if it's very simple things, keep speaking, because you have to be communicating a lot. If you think you're not good enough in speaking, try to improve your speaking abilities. And this is very important because interview is spoken, like oral interview. So definitely you have to be speaking. You were quiet very long time. The third and the final feedback I'm going to give you is before giving any approach, before giving any answer, ask for more input. I gave you only one. Yeah, there's only one input given. Could there be like edge cases? Could there be like not rotated array? Like ask for more information. Ask more. Like you were asking, you started asking like, will there be a duplicate number like in the middle of the interview, right? You should be asking it in the beginning of the interview. Like ask as many questions as you can, and this is going to be very important for you to move on with the questions. So definitely ask questions a lot in the beginning. And then first you give the approach, like very simple approach, then you give optimized approach, and then after interviewer says like, I'm happy with your next solution, the optimized one, and then you start coding. And if you understood the problem, for example, I didn't first of all understand how it should work, but I was trying to like understand the dynamics behind it. Once I found it, what I did is, and then started coding. Like coding was much easier, right? I didn't get stuck trying to understand because I already understood while trying to give you the approach. That's why like coding should be the last thing you should do. Like definitely, this is my final feedback. You definitely have to practice more. Practice makes perfect. That's what Pramp is for. And yeah, I think we are on time. If you have any feedback for me too, I would be glad. If not, like, can wrap up. Mm-hmm. It's totally different. Like, first of all, if you think your programming skills aren't good enough, you should first go to LeetCode and practice alone, because you need to take a very much big amount of time before you go to live interviews, because live interviews will be much more intimidating. It's harder. It's like you said, you are too shy or too feeling weird in the stomach. You can't think because you're under pressure, under time deadline and something like that. That's why, like, try to do practice alone before you think you're ready. And then after you're ready, like, if you think you can solve problems, you have to do is prepare in Pramp, and you should, what Pramp gives is pressure, like peer pressure. Like, there's ton of things that you should be practicing, and then the real interview will be almost the same. I've been to 3 interviews right now, like to Bloomberg and Yandex and one more like interview, Capital, and all of them are identical. Like, there's going to be some random person on the other side, and you have to be speaking, you have to be solving the problem, the same. That's why, like, when you think you're ready to solve problems alone, if you think you can solve problems alone, then you should start solving in the live interview. If you think you're not yet ready to do problems alone, if you think you can't do it even alone, then you should probably go back to drawing board and start solving problems alone. And then after that, you should come back to Pramp and then interview more. I think, yeah, go ahead. Probably it's 10. After 10 interviews, you'll be much better. Like, you'll be, like, I was too shy talking to people. I was really having a hard time in the first 5, I guess, Pramp interviews. From the 6th one, I started talking to people a lot more. Like, probably this is 17th or 16th interview. So after 10, you're going to be just fine. But you shouldn't do like one today, one like 2 weeks from now, one next month. No, you should do like 3 Pramp interviews consecutively. Right after this session, book another one, book another one. Try to do it, because while I was preparing for an interview, I was trying like 5 Pramp interviews in one day. And after 5, my brain was thinking everything is interview. I was, that's how brain works actually. It's this Tetris effect. Yeah. You'll be better at interviewing, you'll be better at problem solving, you'll be better at everything. Like, you'll be much, much more ready. I would say medium, 50 medium questions, 50 easy, like not 50, maybe 30 is enough. 50 medium questions, yeah. After you solve 50 medium questions, you can start coming here and taking Pramp interviews. Yeah, you're welcome. Yeah, my pleasure. Yeah, you're welcome. You're very much welcome. And yeah, see you around in Pramp. Bye.